Okay, welcome to second part of the second lecture. In this part, we would start learning about assigning probabilities to different experimental outcomes. So the three approaches that we would learn for assigning probabilities to different experimental outcomes are the classical approach, the relative frequency approach, and the subjective approach. Starting from the first one, in the classical approach, we start assigning probabilities to the possible outcomes with an assumption that whatever possible outcomes are, the chances of occurrence or the chances of happening of them are equally likely. That's the biggest assumption that we use for this case or this approach when we are dealing with it. So we say that whatever experiment we are dealing with and whatever possible outcomes it has, the probability or the chance for occurrence of each outcome is equally likely. So our assumption here is of equally likely. In this approach, we say that every outcome has got equal chances. This case is really valid for that coin toss experiment, that okay, the tail and the head are really equally likely. There are as much chances for tail as there are for a head. Similarly, we say that okay, if we are tossing a die or doing any other such things, the chances for them are equally likely, and we assume that if there are two outcomes, then their chances would be 1/2 and 1/2 for both. If there were 6 outcomes like 1, 2, 3, 4, 5 or 6 for the die case, we say that their chances, okay, there are total of 6 outcomes possible, the chances for each would be 1/6. So this approach says that if your total possible outcomes are n, the probability for each outcome would be 1/n. So this says that if you have total n outcomes, like here if you have 2 outcomes, the probability for each individual outcome would be 1/n. In case of 2 outcomes, the probability would be 1/2. In case of 6 possible outcomes, the probability would be 1/6. If I say that in a class I have some 30 students and I'm going to select a CR out of those 30 students, or I want to select a representative of the class or any student randomly out of the these 30 students, that what are the chances that a student would get selected for it, we would say okay, for every individual student the chances are 1/30 or 1/30th of the total 1. The chances are 1/30 or whatever percent it becomes if we can convert this fraction into the percentage or into the decimal form. So this was the classical approach. The second approach that we would discuss is the relative frequency approach. This approach comes forward when we don't have such situation, when the situation is beyond equally likely, when the possibilities are not exactly same for each individual outcome. Say for example, in the case, if I said the same case of 30 students, if we say that out of those 30 students there are, say for example, some 12 girls and 18 boys, so they really make 30. But if I'm asking that what are the chances that the student which I would select as a CR or as the representative of the class, that student would be a girl. For being girl, I would never say that okay, it has got 1/30th of the chances. Similarly, I would not say that for that representative to be a boy, the chances are 1/30. Now the chances are different for them. Like I would see that the CR or the representative that I am selected, it has got 1/30 chances if it was generally a random student. But once I am distributing the probability on the basis of the gender, then for him being out of boys, there are possibilities that he would be one of those 18 boys. So the chances for him would be 1 by 18. Sorry, yes, from boys, for him chances would be 1 by 18, but for a boy being the CR, the chances would be some 18 by 30. Like there are 18 boys, so if I say that what are the chances that a boy would get selected, the chances for him would be 18 out of 30, because there are 18 boys, so any one of those 18 can get selected out of those 30 students. Similarly, the chance for a girl to get selected for being CR are 12 by 30, because there are total 12 girls. Any of those 12 girls can get selected for being the representative of the class, and there are total 30 students. So this sort of approach is considered when the frequency or the count of outcomes are not same. Say for example, here the heads and tails were in equal proportion, but when the proportion is not equal, the count of one outcome is lesser than or more than the count of another option, or the frequency of one outcome is more than or less than the frequency of other option or other possible outcome, then we use the relative frequency approach. Similarly, this approach is also used when we have the available data for some particular experiment that we are performing. Like that, if that experiment has already been performed a number of times and we have got certain data, related data available with us, we can make selection or we can make decision based on that data as well. If I share an example with you people, which says, for example, if someone is visiting a doctor in the morning and he is interested to see that what chances are that when I'm going to see doctor or consult doctor, I would not have any patient waiting there already before I reach, or what are the chances that there would be a single person waiting before I reach there, or what are the chances that two patients would be waiting before I reach. So the chances may not be equally likely. Like we may not assume that okay, there are equal chances that there is no person waiting for the doctor before that specific person who is going to consult doctor today, or there are the same chances that one person would already be there, or there would be 10 people already waiting there. So if he takes the statistics or he takes the data of that clinic where the doctor sits, that data says that on some 2 days there have been 0 patients at 9 a.m. when the doctor starts his time of consulting people. There are 0 patients, and that has happened 2 times in the some 20 days, and it has been 5 times that there was a single person waiting for the doctor when he was coming to the clinic at 9 a.m. Similarly, 6 days there were 2 patients, on 4 days there were some 3 patients, and on 3 days there were 4 patients. So it has been the data of 20 days that 20 minutes 10. Okay, so this data says that on 2 days there were no patient at 9 a.m. exact. On 5 days there have been 1 person waiting for the doctor already at 9 a.m. On 6 different days there have been 2 patients, and so on. So now if someone wants to see that what are the chances that when I reach there at 9 a.m. some 3 people would already be waiting before I reach, or some 3 people would be sitting before I am going there. So for 3 people being there, the probability would be some 6 by 20, because out of 20 days, on 6 days, on 4 days, it has been noticed that 3 patients were already waiting for the doctor at 9 a.m. Similarly, if he wants to see the chances, that what are the chances that 2 people would already be waiting for the doctor when I'm going there, so the chances for two patients already available at 9 a.m. are some 6 out of 20, because on total 20 days, there were 6 those days where 2 patients or 2 people were already waiting for the doctor. So this situation cannot be handled with that equally likely or the classical approach, that okay, for 0 patients, because you have 5 possible outcomes, either 0 patient waiting, 1 patient waiting, 2, 3 or 4 patients waiting, so the possibility for 0 patient would be 1 by 5, or the possibility for 1 patient would be 1 by 5. This approach cannot be used, though there are 5 outcomes possible, but their data is different. The data says something different, that how frequently that thing has occurred. The similar case we can see if we are talking about cricket matches. If there is a cricket match between, say for example, Pakistan and India, so we may not assume that okay, there are 50% chances of both the teams to win the match. But why not we have to do that thing? Because we already have the data available with us. We can go in the past and look at the data, that how many times the matches have been won by which particular team. So we may better decide from that data that okay, what are the chances, though those chances may not be 100% accurate. That's what we do in probability. We cannot get 100% correct answers, but those answers are more logical than the wild guesses or some claims which are not done logically or not done in a calculated or educated way. So the relative frequency approach simply says that whatever frequency or number of outcomes you have for your favorable outcome or event, divide that by total number of the possibilities. It says whatever is your favorable event or favorable outcome, count its frequency. Whatever is the frequency of your favorable outcome, divide that frequency with the total frequency. The thing that we did already in the relative frequency time when we were learning the relative frequency. So it simply says that divide the frequency of your favorable outcome with the total frequency of the outcomes that you have, and that's the probability of that favorable outcome. The next thing that we are going to study is the subjective method or the subjective approach. So the subjective approach does not have any hard and fast rule, any hard and fast formula or relation for it. It's something personal that a person decides from his intuition, from his experience, or maybe from some internal information that he has about the scenario, about the situation that is under consideration or under discussion. Say for example, if we take the same Pakistan and India match, maybe we have available data of 100 matches, that how much of the matches have been won by Pakistan or how much of them went in favor of India. But still, if someone is looking at the team members, he can have his personal opinion that okay, I am some 60% sure that this match would go in favor of Pakistan. Why he is saying that? Because he has information of the team members that some particular player is missing from Indian team, which would affect the performance of that team, so there are more chances of Pakistan to win. or some particular player has been added to Pakistani team, which would boost the performance of Pakistani team and make the chances of Pakistani team more than 50% or make it more likely to win. So that approach is always subjective, that's always personal. It has nothing to do with the formulas, with the relations, with the equations, or with whatever. It simply tells that how optimistic you are about something to happen, about some results, about some consequences, or how optimistic you are if say for example I say that okay, there are some 20% chances of Pakistan to win that certain match, so I am thinking that Pakistan is not really good enough to beat Indian team. That's my personal opinion. That has nothing to do with the opinion of other people. That probability would stay valid when a person claimed for it, and my probability would stand valid in my perceptions, in my perspectives, that they do not have to do anything with each other. So once we have got the introduction of the classical approach, the relative frequency approach, and the subjective approach, the thing that we really need to bring into the consideration is the situation which we discussed in the first part of second lecture, that the basic requirements of probability must not be compromised. They must not be violated once we are studying the approaches. So we need to check in all the cases that okay, whether classical approach of the probability distribution or assigning probability to the outcomes really agree with the requirements or it does not violate. So the first requirement was that your probability must always be between 0 and 1. For every possible outcome, your probability must be between 0 and 1 inclusive. It should not be less than 0, it should not be greater than 1. And the second was that the sum of probabilities for different or for all the outcomes must always be 1. So let us see here. While we are talking about the coin tossing experiment, like we see that 1/2 for tail, 1/2 is the probability for head. This 1/2 or that 1/2 is always between 0 and 1. It's not exceeding 1 or it's not lesser than 0. Similarly, their sum is 1, as we did in the first part as well. We did for this as well, and if we are doing for any n outcomes, this would be 1 by n, and we can easily see that if n is a natural number, because for outcomes they can be 0 outcomes, maybe there can be 1 outcome, they cannot be 0 outcomes, sorry. They can be 1 outcomes, 2 outcomes, 3 outcomes, or more than that. So whenever you are dividing 1 with any natural number, your outcome must always be lesser than or equal to 1, and you would obviously get 0 when your event is impossible. So 1 by n would always be between 0 and 1. That thing is clear. The next thing is that the sum of all possibilities for all the possible outcomes, their probabilities must be, the sum of their probabilities must be 1. So if we sum up 1 by n plus 1 by n plus 1 by n up to n times, so we would get n by n, which is equals to 1. So the classical approach really agrees with both of the requirements, that the probability for each individual outcome must be between 0 and 1 inclusive, and the sum of all probabilities assigned to all the possible outcomes must be equal to 1. It agrees well with that. If we look at the second approach that we said, the relative frequency approach, we would see that there are some, if we are talking about this thing, the 30 student problem, where we were selecting any girl out of them or we were selecting any boy out of them. So if we look at this, there are some 12 by 30 chances that the class representative would be a girl, and 12 by 30 is really lesser than 1. It is greater than 0. It lies between 0 and 1. Selecting a boy out of those 30 students being CR of the class has 18 by 30 chances, which are really less than 1 or they are greater than 0. So the first condition gets satisfied. The second condition is, if we sum them up, that 18 by 30 plus 12 by 30, they become 30 by 30, which is 1. So both these conditions agree there. Similarly, if we consider any other example for the relative frequency case, like maybe we consider a jar. This is a jar, you need to agree, huh? And that jar has some maybe 5 black marbles, some 3 white marbles, and seven blue marbles. So the total marbles are 3 plus 5 and 7, 15 marbles. If we are going to look for the chances that if a randomly chosen marble is black, that can have 5 by 15 chances, because there are total 5 black marbles. So that marble would be, if I'm interested in the black marble, so that would be one of those 5 black marbles, and there are total 15 marbles, so its chances would be 5 by 15. Similarly, for the marble which I chose randomly, for that marble being white, the chances would be some 3 out of 15, and for that marble to be blue, the chances would be 7 out of 15, and if we sum them up, the chances would become 15 out of 15, which satisfies the second condition. Similarly, be it 7 by 15, or be it 5 upon 15, or be it 3 upon 15, all those fractions are lesser than 1 and they are greater than 0, and the 0 probability would be for an impossible event. If I say that, okay, what are the chances that if I pick a marble randomly, that would be green, so there cannot be any chance of getting a green marble out of the jar. That jar contains only white, black and blue marbles, so the getting green would be an impossible event. Similarly, for the subjective approach, as we don't have any hard and fast rules, only the care must be taken that when we are assigning probability to any event, because we are making our personal opinions, that probability assignment must be between 0 and 1. Whenever we are saying about anything, we should not say that, okay, I have 1.5 probability of the case that Pakistan would win. No matter how patriotic I am, my chances or my claim must be between 0% to 100%, or between 0 and 1. Similarly, when I say that, okay, there are 60% chances for Pakistan to win, for Pakistan to lose the match, the chances must be 40%, so that their sum becomes 100%. So in this case, we personally need to take care of the assigning probabilities in a way that probability is always between 0 and 1, and similarly we need to take extra care that if there are 2 possibilities, there are 10 possibilities, there are 100 possibilities, and we are assigning probabilities to each one of the possibilities, whenever we are summing all those possibilities, the sum must be equal to 1, or that must be equal to 100%. So that's all for assigning probabilities through different methods.